afternoon, and thank you for joining us in the Innovations in Lightweighting Technologies and Methodologies session at CAR-MBS 2020. This session is sponsored by Altair. This session was pre-recorded. If you have any questions regarding the virtual MBS experience, please feel free to ask those questions at the information desk in the virtual lobby. Please also take a moment to visit the virtual exhibits in the exhibit hall, and if you'd like to earn CEU or PDH credits for participating in CAR-MBS, please visit our MBS page on our website at www.cargroup.org to access the registration link for CEUs or PDHs. Once again, thank you for joining us today. I'm pleased to present session moderator, research engineer at the Center for Automotive Research, Shashank Modi.
Good afternoon, everybody. This is Shashank Modi from the Center for Automotive Research. This is the Enlighten Award Q&A session. The awards were announced yesterday. And today we have the winners and the runner-ups of the various technologies, and we'll have a great discussion about those technologies and the stories behind them. So first of all, congratulations again to everybody. And I want to start with a brief intro, just 2 minutes of your name, your company, and what your product is. So starting with Marco.
Yeah, good afternoon, good evening, and good morning, everybody. So I'm responsible for the product development in Marelli Ride Dynamics. Ride Dynamics is a business unit made by merging together the previously known suspension systems components and shock absorber components. And so we developed any kind of structural components for suspension needs and also the damping components recently. So we deal with, of course, lightweighting and redesigning technologies for control arms, knuckles, links, subframes, and cradles. That's why in the last 5 to 6 years, we are scouting the applications also for composite materials to have the dramatic weight saving that cannot be reached by classically utilizing aluminum and steel.
Thank you. Salvador?
Yeah.
Okay, good morning. That's Salvador Sottile, Advanced Application Engineer at Marelli Ride Dynamics here in Turin, the R&D headquarters. And our award is the Advanced Sheet Molded Compression Suspension Steering Knuckle.
Thank you. Stefano?
Hello, everybody. This is Stefano Rosta from Germany. I'm the global head of research and development in the business unit of chassis composite for the company Mubea. The chassis company business unit is one of the innovative parts of the chassis division. And the product we got an award for is a tension leaf spring made out of GFRP, glass fiber reinforced plastics.
Thank you. Takimoto-san?
Yes, hello, this is Takemoto. I'm from Nissan Motor Company in Japan. I engaged in research of CFRP lightweight vehicle body research. Thank you. Yeah.
Thank you. Todd?
Hi, my name is Todd Muck. I'm with Toyota Motor North America R&D. I'm in the Technical Strategy and Planning Office, technical leader in the Advanced Commodity Development Group. Prior to that, 25 years in seating. So thank you.
Thank you. Ryan?
Yeah, I'm Ryan Hilligan. I'm Director for North America Sales and Marketing for Mubea. And our product is the glass fiber reinforced plastic tension leaf spring. Thank you.
Thank you. Marcus?
Hello, I'm Marcus Fischer. I'm Vice President at ZF or CF, working in the Active Safety Division, and I'm responsible for the foundation brakes and the EPB globally. The product we are entering is the EPB for heavy-duty application. Thank you very much.
Thank you. Richard?
Hello, I'm Richard Yan. I working for Altair Engineering as a Senior VP of the companies. I lead in the team for global industry verticals. So essentially, we are looking after all the verticals that understand the challenges of these different verticals. And for the lightweighting, especially focus on automotive. And we would like to understand how the application, how the challenge is going to be considered by the industry so that we can drive the business of the Altair, which is applying simulation, data analytics, and high-performance computing to achieve the goal for the product design. Thank you.
Thank you. Messiah?
Hello, everybody. I'm Innami of Body Design in Nissan, Mexico. Thank you for giving me a chance to talk. This year, the new Sentra was fully remodeled and released. The car has an all-new upper body and underbody as a new platform. BIW with this new platform greatly improves the potential for car crash performance and for dynamic performance. It also contributes significantly to the weight reduction of the vehicles. New cars equipment this new platform will be sold in all over the world. And this is the first time, first appearance in North America market. This time, I felt that I was able to contribute to the weight reduction promotion in automotive field. Thank you so much.
Thank you. Glenn?
Hello, my name is Glenn Koval. I am the General Manager of Engineering at Harley-Davidson. Today I'm here representing Harley-Davidson for the product Livewire, which is our first all-new electric motorcycle. I was the chief engineer on that project.
Thank you. Frank?
Yes, hi everybody, it's Frank Bellato. I'm with DuPont, Transportation and Industrial Business. I'm the market manager for the Americas and cover all the adhesive technologies that DuPont has. They were heritage Dow products that came over in the new DuPont that are all adhesive technologies for the transportation industry. Our technology here today is our BetaSeal X2500 polyurethane structural adhesive. It's used for bonding lightweight thermoplastics and enabling lightweight modular assembly and lift gates.
Matt Parkinson, Senior Manager of Application Development and Composite Technologies with Performance Materials, here with partner Toyota on the Sienna CPAC.
Thank you and welcome again. And I want to mention that I was part of the judging panel. As discussed yesterday, we had really good entries this year. So if you have won or are runner-up, you had really good competition. And there were multiple instances where we had a tie and we had to do a tiebreaker. So this here has been unique. First, we are doing it virtually, but also the quality of entries were really good. So congratulations again. So I want to start first with the full vehicle winner, that is Harley-Davidson, which won the award for the Livewire electric motorcycle. And Glenn, I am a big motorcycle fan, and for me and many of my friends, a big part of motorcycling is the sound and the manual transmission and really riding the motorcycle. So, with this electric motorcycle, what are the unique selling points of Livewire? What kind of customer feedback have you got? And why should I consider buying it if I had the money?
Yeah, all great questions. When we set out with the Livewire, we had to rethink how we do motorcycles. And look, sound, and feel is three of the biggest tenets with Harley-Davidson. And with Livewire, we wanted to make it look different, make it feel different, but still make it be a Harley-Davidson in its DNA. And when we think about EVs, the benefits there are accessibility and confidence inspiring to people that may not be traditional motorcyclists, where you don't have the heat of the engine or the exhaust, you don't have the clutch that you need to pull in. But we don't feel that is a sacrifice. We give up, we bring it in performance. If anybody has ever been in an electric vehicle compared to a traditional fuel vehicle, the acceleration is second to none. And when we took that electric vehicle and made it a Harley-Davidson, we did develop a sound with it. Our driveline does have a beveled gear set that we tuned to make it sound like a jet turbine that we have unique to Harley-Davidson. We also added a feel, so we added a haptic pulse when you're sitting at the light to alert the rider that you're fully enabled and that the throttle is there, and it feels like a heartbeat. We designed it around a heartbeat of a human that comes up through the whole vehicle. So we brought elements of our look, sound, and feel into this Harley-Davidson motorcycle that we feel is unique to any other motorcycle in the world.
Thank you. And I actually did visit a Harley dealer and look at the vehicle, and it's really beautiful. And I'm really looking forward to ride it and try it sometime. So you developed aluminum chassis for the vehicle. Did you look into other materials such as composites for your reducing the weight of the chassis versus the entire vehicle?
We did. On the chassis, it was a brief look. Because of the stiffness requirements of how you handle the forces and turns and coming in and out of turns and what that stiffness looks like, we settled on lightweight aluminum. But we did bring composites around many of the other components that don't require chassis stiffness. So fenders, body panels, all the brackets that we use, most of them are of different composite materials.
Thank you, Glenn. My next question is for Nissan, for Nissan Sentra. And we saw yesterday that this vehicle has a 30% or more utilization of ultra high strength steels to reduce mass and improve ride and handling. My question is similar to what I asked Glenn, that did you look into other materials such as aluminum for lightweighting, and why did you went for steel versus other materials?
Yes. In recent years, there has been a higher requirement for crash performance, such as small overlap and it's kind of crash energy increasing. The new body has increased the high tensional steel adoption ratio by 12% for above 980 megapascal material. Apart from high tensional steel adoption, there are lightweight items such as using aluminum material and laser welding for joint strength and rigidity increasing. Currently, we were not able to adapt to C-segment vehicles because cost was a bottleneck. So, if these lighter weight items become more cheaper, we would be able to adapt these items more in the future.
Okay, so it seems like cost was a big decision factor here.
Yes.
In your optimization, what kind of simulation technologies did you use, and did that play a big part in reducing the mass?
In order to develop a more lighter optimized body, it is necessary to consider variations factors in design and evaluation and manufacturing. Since, as you know, crash performance is a dynamic phenomenon, it is necessary to set more dynamic design factors or a kind of index and need to make a robust design. A CA simulation reproducing can reproduce these necessary factors is very, very important as the evaluation method for us. And in addition, in the future, I think it is necessary to change the thinking way, like giving crash reaction force to another components apart from body, such as seat or interior parts. So, it also will be necessary to develop CA technology that can accurately reproduce those factors.
Thank you. And really, it's a new platform, and I'm looking forward to test riding the vehicle. It looks great and has a good mass reduction. And again, congratulations. So I want to move on to the module category, and the winner for the module category is the Toyota resin seat. And I want to ask Todd that, achieving mass reduction is one thing, but achieving mass reduction with cost reduction is a significant achievement. But I want to first ask, why target the seat for this lightweighting initiative?
Well, thank you, Shashank. For the 21 Sienna, the third row seat acts as a load floor, as is a seat. So the weight of the seat, the customer has to use, the function to stow and to raise it back up. So the weight of the seat really impacts their kind of customer experience. So this was a win-win, not only lightweighting the vehicle, but actually affecting the customer's efforts directly. And and Monty Kerr, the chief engineer, wanted to make sure that anything we did lightweight was directly felt by the customer. So that was very important to us.
So I guess resin was selected because it offers a lot of part consolidation opportunities. What other materials did you look into, and did you consider magnesium and other materials, and why was resin solution chosen over those other solutions?
Well, that's a great question, and I hope not to offend any of the attendees. But, steel and magnesium and resin, the competition that we created within our design group was very, very enjoyable, I guess to say. Competition is always a good thing, and when you're developing magnesium for a product, magnesium is a very good product for its applications, but the post-processing, the tooling span over the 10 years, those type of things really, kind of impacted the cost when it came to magnesium. The injection molding was a little more comparable or easy to, incorporate many more parts, including, the nut inserts, for instance, and the after. That goal of shoot and ship part was easy to be met with the injection molded design.
Do you plan to use similar seats for other vehicles in the future?
Yeah, and I think one of the things we said yesterday in the awards, this will change, I think, the seating in Toyota for a while. This has been a very humbling, but also kind of a new thing that everyone's really excited about.
Great. Any specific manufacturing challenges that you face that you want to mention?
Well, there's always manufacturing challenges, especially when you're dealing with a new part, a safety part. BSF support with the parameters and the tooling design, the manifold designs, the supplier, Flex and Gate is our molder, their input. Our supplier engineering department has been very much involved with our engineering group to make sure that all those parameters are set, and we have kind of that pre and post check to ensure the quality of the part to the customer. That's something that we take very seriously to make sure that each part meets every one of those parameters and functions as it should.
Well, thank you. I think it's a great invention and a very good example of early design collaboration between an OEM and suppliers. So congratulations again, Don, and the entire Toyota team. I want to move to the runner-up for the module category. That's ZF for the electric park brake. And Marcus, it's impressive to see mass savings and the volume sold by ZF by this technology. So why is the electric brake technology an important innovation for the automotive industry?
Thanks, Shashank, for the question. And for me, the EPB is still the exciting product because when you really look at the vehicle, you eliminate the mechanical parts on this side. That means in the past, if you compare it with the traditional brake, the mechanical pullers, the cable pullers and everything, that's for sure an ease in manufacturing because we just have to route cables at the OEM. Then we have the brake on caliper, that's another ease and standardized, I would say, module. And then look at the interior. You know, you can replace the brake handle. You can use it for a HMI interface, or if you have the brake pedal, like for trucks, you know, sometimes in the footroom, you have to do crash protection. And this one is all can be eliminated, you know, with the heavy-duty EPB. So the EPB as mechanical system, you know, the one thing, especially for the trucks, was the go to weight savings, but you get the convenience factors. You know, that means really you can have EPB apply when you leave the vehicle. If the service brake should fail, which typically seldom happens or never happens, but you have the EPB with a dynamic deceleration. So you can stop your vehicle safely just by pulling this little lever. And I think that's really this technology leap of the motor and caliper in the automotive industry. That gives really a lot of opportunity, once again, for safety, but also for the design of the interior of the vehicle. And that makes the product so excited.
Yeah, it really seems like, you know, the electric park itself provides lightweighting, but then there are also lots of secondary mass savings opportunities that are offered by this technology. And the sedan that I drive, the Honda, it has electric park brake, and really I second you on convenience. I just push one button and the park brake is there. You don't have to put levers and anything like that. What were the challenges during the development of this product, and what further potential do you see with this technology?
The challenge was for sure 35% more load capability, short development time, and that's all within a budget and within cost. So in the end, we put together a global team that really, one team worked on the actuator, the other one on the spindle. You know, we got it together as a system. It has to be right. You know, it's also about the release time. I think our EPB at this time it's the fastest one for heavy duty application to release. That is one of the biggest challenges, and then find the right materials, because it's always a balance between a safe solution, but then it has to be cost effective. So we started some of the plastic gears. We had to upgrade the materials to sinter metal, and that was really the development of the actuator. If you see the concept over there as a mechatronical system, it has a lot of potential. On the one hand, in this case, we stepped it up to the heavy duty, but you can use it also, let's say, for smaller vehicles, you know, like the European classification A and B segments. You know, we just announced in 2020 that we launched a front EPB. So you have the EPB move to the front. Advantage for the OEM is, once again, it has shorter cables, better performance on the front disc, and the OEM has advantage on the rear, that he can use his drum brake, you know, for standard vehicles. And if he comes up with a performance vehicle, then he can install a rear axle with a disc brake, you know, just for the service brake. And you have to look out at the mechatronical system. You can do really, let's say, an automatic play of the brake. You can use it as a park lock, you know, instead of the park lock in the transmission, another weight-saving mechanical part. And I think if we look at the EPB as a system, integrated in the braking overall architecture, it has a lot of potential, and we have still a lot of exciting new products coming up to 2030, and I'm very excited about this technology and the future of this product line.
Yeah, and it seems like it has a great potential across the fleet. You know, this is for heavy duty, but you know, it's a small part, but then the volumes that it can cover are great and can provide multiple opportunities. So thank you for participating, and congratulations again.
Thank you.
I want to move on to the enabling technology. For lightweighting, the winner for this technology is Mubia, the glass fiber tension leaf spring. And I want to congratulate them and start with Stefano. The GFRP leaf spring is not a new technology, but the way you have implemented technology is really innovative. Can you give us, you know, few points of what makes the Mubia product different from similar solutions?
Yeah, sure. So you're right in terms of the fact that the GFRP leaf spring are not new in the market in a more general way. I think in the past decades, and even in the actual history of automotive, there is a couple of applications that have used GFRP or are using GFRP leaf springs. So that part is not new. However, the longitudinal GFRP leaf spring have so far only been implemented as a replacement for a one layer steel leaf spring, which means we're talking about axle systems, suspension systems that have only a single linear spring rate characteristics. So this is okay, obviously, for lower payload vehicles or say lower ride comfort requirements. But the truth is that if you look in the market nowadays, most of the cargo vehicles or even pickup trucks or similar do use multi-layer steel leaf spring, meaning a pack of different amount of layers, which allows for more rates, dual rates, for multiple rates. So the tension leaf spring is designed to be a replacement exactly for this kind of application. So for multi-layer steel leaf spring, because due to its concept allows for a progressive spring rate characteristics, and that's basically the main difference in what it can be used for. Additionally, it's only one layer, which replaces a amount of 2 or 3 layers, which means the weight save potential goes up to 75%, meaning in absolute values, we are talking about somewhere between 60 and 100 pounds of weight save in the axle system, and it's unsprung mass, obviously. So even the lightweight costs are good and justify an implementation of this kind. Additionally, obviously, since we don't have the engagement of different rates, because the force displacement curve is continuous, there is a huge ride comfort improvement. This is another differentiation point. So it's very important, and it's something that even the end customer will notice. And obviously, as a result of this, there is a homogenization of the body natural frequencies, which means the whole thing is much more comfortable through all the loading conditions of the vehicle, whether it is unloaded or fully loaded.
So you said always the multiple steel leaf springs will be replaced by one CFRP spring because of the progressive spring characteristic. So right. is this the design which leads to that progressive spring behavior, or are you also have different material densities across the leaf, or is it same material, but the design is more important?
Correct. So it's the material itself is the same along the whole spring. Even the fiber volume contents are the same along the whole spring, which is an advantage that we have because of the process that we use, a pre-preg, so fiber pre-impregnated pre-material that we use for the springs. The real trick on the whole thing is basically the geometric nonlinearities that happen because of the whole concept, and I'll explain this. On a current multi-leaf spring application, there is actually the pack of leaves, but there is also a shackle. And when the pack of leaf is deflected, it changes its length, and this length compensation is done by a shackle that rotates around the rear attachment point. The tension leaf spring does not have any shackle anymore, so it's a mono leaf that integrates the shackle itself. And by doing that, you reduce the amount of degree of freedoms in your mechanical system, making the tension leaf spring an over-constrained system. And having an over-constrained system means that when you deflect the spring, you additionally to the bending that you have anyways, you have a tension, a progressive tension that happens in the material. And because of that, the overlaying of bending and tension leads to a progression. So it's really the fact that the system is over-constrained. This obviously only works if you have a material that allows you to go that up in terms of stresses. So that wouldn't be that easily doable with steel. So we try to use characteristic of the material, so the advantages that we have from the material, and combine it with a smart idea so that we have we can go further in the advantages of the system itself.
Thank you so much. And I think it's good for lightweighting, but it also is, I think it's a beautiful solution because, the part itself, it replaces those multiple steel strings and just a single part with this innovative design looks really good. Thank you and congratulations.
Thank you.
I want to move to the runner-up for this category, the enabling technologies. There's DuPont for the beta seal bonded thermoplastic lift gates. Frank, congratulations to the DuPont team. And I want to ask adhesives, they play a very important role in multi-material, mixed material design. Every automaker is looking forward to putting right material in the right place. And there are multiple adhesive solutions out there. So again, I want to start with a similar question. How is this product different from other adhesive solutions?
Yes, thanks, Shashank. Thank you for the question, and it's a relevant question. I think there's a variety of ways to answer this question, or a variety of points to point out. For example, this adhesive system is formulated for these types of applications. So what I mean by that, what's important is that it has the right balance of cured properties needed for mixed material joining. Specifically, it has an optimum balance between the adhesive modulus, the elastic properties that are retained, and the bond strength, which are all critical, of course. So this product has a high enough modulus to provide the strength and rigidity to the final module, but also has the right elasticity remaining to mitigate things like bond line readout on Class A surfaces, which was a concern early on in the application development. And that balance of properties I mentioned is important for bond joints that include a mix of materials, including thermoplastics, like in this case, because the materials may have different thermal expansion and response to temperature changes, things we've talked about in the industry for a number of years. So these types of mixed material bond joints really require adhesives with some elasticity or higher levels of elasticity, the right modulus, that they stay flexible at all the temperatures that the vehicle can experience on the road, in order to manage the relative motion in the joint that it may experience, and manage the stresses that may develop as a result. So you have to formulate with these things in mind, and that's what our technical team has a deep know-how in doing. Also, another point is this system is specifically formulated for accelerated curing through external heating. So in this case, it's by infrared heating. In the manufacturing process, the adhesive is heat staked at some select locations by IR around the module perimeter, and that provides quick green strength and allows for subsequent manufacturing operations to be performed, and the rest of the bond line will cure by chemical reaction of the two mixed materials. And finally, this is really one of the only adhesives on the market that we're aware of that can meet all the OEM customer specifications for composite bonding, or their specifications for mixed material joining, or they may call it dissimilar material joining. So in some cases, a specific level of bond strength is required in those specs, and this system can meet all those across the spectrum.
Yeah, it looks like a really good enabler for mixed material joining, especially composites. What other applications are you targeting? Liftgate, I see, is what you submitted, which you worked with Jeep. What other subcomponents of the vehicle are you targeting for this technology?
We do some applications in deck lids as well, some mixed material deck lids, some body structures that are made of carbon fiber, and we have metal reinforcements, are other applications that we do today actually, and are working on additionally for similar types of primarily adhesive joined. May be in a combination with a fastener or a thermal method, but or in some cases fully adhesively bonded, like we see in the liftgate here.
Okay, thank you. Looks great, and I think the adhesive market is only going to grow as as lightweighting becomes more and more important because of the regulations, but also because of the added mass from electric vehicles and autonomous vehicles. So adhesive, I see, and car roadmaps also show that will play an important role in the future. So congratulations again, Frank, and the DuPont team.
Thank you.
I want to move to the future of lightweighting category. The winner for this is the Marelli SMC suspension steering knuckle. And Marco, I want to start with congratulations to you and the team.
Thank you.
So reducing unsprung weight is a target of most vehicle programs, and every gram matters, and so it's really fascinating that you were able to achieve 25% lighter than aluminum and 50% lighter than cast iron steering knuckle. What factors contributed to the selection of chopped carbon fiber SMC for this project, or was it glass fiber? I'm getting confused with carbon.
No, it's totally, yeah, it's for chassis components, for suspension components, totally carbon fiber, because usually the design is driven by static stiffness or dynamic stiffness. So to reach right stiffness level, we must use carbon fiber for this kind of components. We started some years ago asking ourselves how to reduce, how to really cut dramatically in a big steps the weight of our components. And so we started selecting the right materials. So as I said, carbon fibers associated with thermoset resin in this case. So this is a vinyl ester resin. There is a very good compromise between manufacturability and also the let me say environmental impact of the resin. But so starting from the best materials, then it takes us some years to select the perfect compromise in terms of manufacturing process, and SMC, so the sheet molding compression process, allow us to have the very reduced manufacturing time, a really small numbers of tools, practically one tools. In some cases, we have maximum 2 tools to manufacture our parts. So there are no junction, no complicated bill of materials. The aluminium sleeves and all the metal insert that we need to concentrate the loads, to exchange the loads between a knuckles or a control arms and the other parts of the chassis can be directly introduced into the molds. So this manufacturing process gives us flexibility in adoption of different mixtures in terms of percentage of fibers, a different resin, but also allow us to place directly aluminium or metallic sleeves and very short manufacturing time. And also interesting characteristic for the designer is that our material and our process, it leads at the end to a quasi-isotropic material. So we cannot afford to have to deal with let me say materials like those utilized in the aeronautics industries. From actually I come because I'm an aeronautical engineer, so we cannot afford to have a tailored multi-layer materials, because the loads and the stresses for chassis components and for car components are much more mixed. Let's say the mission is less defined than those for a wing panels, for example, or for a fuselage ring. So having the possibility to deal with quasi-isotropic materials give us a big advantage in terms of easy design and flexibility and robustness of our application. That's why SMC with chopped fibers, high percentage of carbon fibers, is a very good compromise for manufacturing cost, isotropic design, and performance.
And you're right. You know, we cannot start comparing things to aerospace and directly copying technologies into automotive, because the cost benefit equation is very different. But as soon as people start talking about carbon fiber or any kind of composites, the first question that comes to mind is how do I justify the incremental cost? So what is your business case for this technology?
Well, as of now, for low volumes applications, we have already interesting business case because of 2 main factors. One, as I said, is the reduced cost for the tools and the reduced numbers of tools to produce the parts, especially for cradles and subframes, and also to a certain extent also for knuckles. Second factor is of course the raw material, the base material. It is costly, but it is decreasing very rapidly. We are working in the last 5 years with carbon fibers manufacturers and also with compound materials providers to select the best solutions in terms of carbon fiber productions. Also, we are studying a certain mixture of virgin carbon fibers and recycled carbon fibers, but especially we are scouting, and we have actually demonstrated the validity of starting from, let's say, less costly, like a 50K carbon fibers, then applied in a certain way to our application to reach the higher request in terms of stress resistance. So I am saying that the cost of raw materials is decreasing quite rapidly, and what we forecast some years ago is happening actually. Till now, as of now, the variable cost of the part is still, of course, not at the same level of aluminum, but the weight reduction on the Unsprung mass can be, let me say, well recognized by the car makers. So a certain amount of premium price is in the let me say, in the plan of car makers anytime you are able to reduce Unsprung mass. And when you also consider the tooling costs, so the amortization values for our parts, I can tell you that as of now, for low volumes, there is already quite a good business case. In a few years, in a period in between 5 to 6 to 7 years, also medium volumes, some components for cars in medium volumes will become very much interesting in terms of business case when we adopt the carbon fiber SMC technology against aluminum.
Yeah, and you're right. Automakers are willing to pay if they do see a good cost versus benefit equation, and because this is unsprung mass, it provides additional benefits of good handling as well.
And also for the comfort, for the MVH, because don't forget that we are scouting also the behavior and the advantages coming from our technology on the MVH, and we are handling with some interesting values in terms of acceleration that comes into the body, at the driver's level, thanks to the different dynamic function and transfer functions of these carbon fiber parts.
Right. So I want to ask you and Mubia as well, that we have seen a lot of composite solutions this year. What other areas do you think might be preferred by automakers to switch to composites in the future? Let's say in a 2025, 2030 time frame. Technologies like what you're showing here, Marco, with the chopped carbon fiber, and with what Mubia showed with the leaf GFRP leaf spring.
Yeah. So for let me say, already now there are some interesting applications that we're able to design and to produce for cradles and subframes, as I said, not just knuckles and control arms, and also for the battery box of the battery electric vehicles. For the BE vehicles, we are starting applications for the big battery box, especially those that practically stays below the floor in between the two axles, between the two wheels. So for big battery box, you can achieve it very interesting weight saving when we consider SMC technology.
Right. The battery box is a hot topic all the industry, steel, aluminum, as well as the composite industry is pitching for it. But I think this is very innovative, and congratulations again for winning this award. I want to move to the runner-up for this category, that is the Nissan aluminum CFRP body side. Mr. Bagomato-san, the injection molded CFRP over aluminum is an innovative product as it reduces mass while controlling cost. What challenges needs to be addressed for this technology to be used in production vehicles? Because I see this is in the future of lightweighting category right now.
Yeah, thank you for your question. The issue for production vehicle performance assurance and quality assurance against the external environment and production variations. Regarding the external environment, it is the durability and reliability against change in CFRP physical properties, strain rate dependence characteristics, and linear expansion coefficients, which occur due to external temperature and humidity. Regarding production, quality assurance is provided for the control of fiber orientation by injection molding and the variation in bonding strength between metal and CFRP. At the research stage, we are investigating under the worst condition. So we think that development from the viewpoint of robustness is necessary. That's all. Yeah, thank you.
What kind of simulation did you use for the final product? Was it FEA, topology simulations, things like that?
Yes. Yes, and it's necessary to topology analysis and impact analysis. And in the future, I think the AI, it is easy to develop the topology, but the cost is expensive, I think.
Right. Yeah. Yeah, and Richard, you would agree that AI will play a big role in the future with simulation, and Altair is developing a lot of products to support these lightweighting initiatives. So my first question to you is, what is the future of simulation, and how is simulation driven design will contribute to the lightweighting products that we are seeing today and in this Altair Awards?
Thank you, Shashank. I think for Altair, we are always envision the futures, and where we are seeing the future is coming from this how the Altair can grow. We are seeing the simulation is going to drive the design, so we call it simulation-driven design, which means that the simulation is going to lead you to the right design. A lot of people were talking about have a right material in the right place. Typically, I will ask, where is the right place? Right, so simulation tool allow us to visually to see where is the load pass through the structures and where do we need to place the material. The second one that we are seeing is the data analytics. In the past 30, 40 years, we have been doing so many simulations, so many testing. Now we should try to capture those designs and to reflect into the simulation as well. And this is a lot of companies are talking about it. The key is where the data is coming from, right? So Altair has a technology we are envisioning, simulation plus data analytics combining together is going to drive the future of the design. But this is also rely on the high performance computing and the cloud. So you're asking about how Altair envision the future. I would say, combining the simulation, data analytics, and cloud is going to drive the future of the design.
Okay. And as I said, Richard, you said yesterday too, we received very good entries this year. What changes did you see in the entries submitted through the last 8 years? Because you have been doing it since a long time.
Yeah, indeed. I think this year we are seeing the trend essentially. If you look at the summation from the 8 years ago, and each years that we are getting a lot of entries, and we are reviewing those entries with judges, we are seeing the trend that get into electrification, especially this year. We are seeing the trend get into electrification. We are seeing the trend discussing about the sustainabilities. So Carla, yesterday mentioned about that we are going to get into a new category potentially to talk about the sustainabilities as well. And we will discuss with Carl to see what kind of category we can bring to the industry so that we can inspire people. Also, we are seeing a lot of mixed materials because, again, when we talk about the lightweighting, we talk about mix many different material. And those material could be from the metallic, could be from composite. but we need the bondings, we need the adhesive, we need the joint methodologies. So we are seeing the technologies, the regulation is going to drive more and more of this kind of innovations. And this year particularly, we are seeing a lot of composite applications, and I'm seeing this probably the trend that we are moving forward to, right? And a lot of companies are using simulation-driven technologies too. So this is what we see this year particularly, that we are seeing those entries.
Okay, so thank you so much, everybody, and congratulations again. Great discussion, and I wish you a good day.